We have designed a prototype for the purpose of farm automation which will immensely benefit farmers when it is utilized efficiently. Our project mainly focuses on the following aspects. The first one is power management, as shown here. Next, the robotic controlled arm for farming using image processing. The third, monitoring and controlling the field according to the parameters that are constantly being monitored and processed. Next is the Android application controlled automation, which uses dashboard version 1 for monitoring and visualizing. Instead of Android phone, if an iPad is used, it will support the higher version of dashboard, which provides a major advantage in terms of monitoring and also controlling the aspects of the field with interfacing with the lab view. Fully automated control system through the internet is possible from anywhere in the world using laptop and computers. Here we have the main front panel of the server system. Now the client can access the main panel of the server system using the Internet Explorer and by typing this URL. We can see here, this is the server system and this is the client system. The person handling the client system can take control over the server system in any part of the world through the internet just by clicking request control of VI. By this way we can control the farmland from any part of the world. We can enable the robotic arm. We can switch on or off the automatic solar panel tracker. We can monitor the tank level. We can start or switch off irrigation, and we can control the spraying of fertilizer. All this is done by a web publishing tool. This part shown here is the automated solar tracker, which is a part of our power management system. Here we are using two LDRs to align the solar panel in the required direction perpendicular to the sun ray. Now as the sun ray falls on this LDR, the panel automatically aligns in that particular direction. After some time, when the sun ray falls on this LDR, the panel automatically aligns its position according to the ray. This is the panel for turning on the solar panel. The irrigation system shown here can be scheduled, manual or automatic. The scheduled irrigation can be activated as per the requirement of the farmer. The automatic irrigation will be activated as per the soil moisture content. Whenever the moisture content goes below a threshold value, automatically the automatic irrigation is activated. The manual irrigation can be activated using the GUI over the internet or by this Android application. Even in remote places where internet connectivity is not available, irrigation can be activated using GSM through the phone's DTMF. This is done by the Sakura board. When the farmer sends command over the mobile, it is received by the Sakura and it takes the appropriate decision. In this case, it is to activate the irrigation. To demonstrate, we are calling to the mobile, which is connected to the Sakura board, and it is in automatic answer mode. Whenever the call is received by the phone, we dial the required number for irrigation. Now 1 is pressed to activate irrigation. We can deactivate the irrigation by pressing the required number. All the inputs from the field, such as temperature, humidity, soil condition, are fed to the chip kit and interfaced with the lab view. Look at the sensor network, which analyzes various parameters such as the soil moisture, security breach, temperature and humidity. The photo detector here will sense the light and automatically turn on the solar panel tracker. This is the panel for turning on the solar panel. This sensor here is for security purpose. If anyone intrudes in the farm field, automatically there will be an alarm, as you can see there. Now automatically the alarm will be activated, and even in the dashboard it will be activated. There are two types of soil present here. Based on the condition of this soil, the values are being plotted here in this graph. Now when the sensor is kept in the other soil, automatically the appropriate values related to that soil will be shown here. Now comparing both the soil conditions, the appropriate action would be taken. We can also view using this dashboard application. The moisture content varies depending on the soil condition. The plots of the two soil types are shown here. Now the same plots and the same values can be observed in this dashboard run by the Android application. We can observe the field conditions and also the parameters which are getting changed in this dashboard or in the mobile. As we can see, we can monitor the tank level, we can see the humidity percentage, we can monitor the rainfall, we can activate irrigation, and as soon as it is activated, it will be notified in this dashboard application. We can also activate fertilizer, and it will also be intimated in this dashboard application. Alternative energy sources will also be displayed accordingly. Using this Sakura board, we are controlling the 3 servo motors here using the PWM pins. We have programmed the servos individually so that each moves in the prescribed angle. Each LED blinks corresponding to the servo which is in action. This robotic arm will be able to move in X-axis, Y-axis, and this will be able to cut the ripened fruits. In our prototype, the robot traces the black line as a line follower. In real time, it can follow the path by image processing. The camera mounted on the robotic arm will keep acquiring the images of the field and then send to the lab view for processing. As explained before, this robotic arm is used for cutting the ripened fruits. Now, when the fruit is ripened, automatically it will be cut by this arm. This process is shown in the front panel of this lab view. The image is acquired, and when it is detected as a ripened fruit, automatically the red LED will glow since it is a tomato. Now we will demonstrate what happens if another fruit is detected. As shown here, this is an orange. Since it's an orange, the image acquired here is processed, and in the fruit detection palette, the orange LED will glow. Next is the image processing part. The image is acquired and then it is detected as to whether it is ripened or not. If the fruit is ripened, it is cut. There is also analysis for the purity of grain and also insect detection. This part shown here is one of the main part of the image processing section. This is used to find the purity of grain. For demonstration purpose, we have two types of grains, this and this. Now the acquired image is the image of rice and the purity is given here. Which is about 85%. Another sample for purity check is shown here. The acquired image is shown and the purity of this grain is about 70%. The Ethernet feature of this Sakura board has been used in our project, and this enables us to make the Sakura board act as a server. The program which is dumped to make the Sakura act as a server is shown here. The local IP address of the Sakura board and the MAC address are highlighted here. By this, we can get access to the Sakura from any other device through the web by typing the public IP address of the router, and port forwarding has been configured in our router, which will connect the GR Sakura to the internet. This is the web page through which we can access the server and control the various activities in the farm. This is the memory card which is inserted into this SD microcard slot and interfaced with the Sakura board. The SD MMC header has been included to interface the SD memory card slot to GR Sakura. This is the program to access the stored data from the SD memory. Now, if the farmer types 5 in the serial monitor, the farmer will be able to retrieve the temperature and humidity for a period of days. You can see the temperature and humidity for a period of 30 days in this window. There are various panels. This is the image acquisition panel. The acquired image of the fruit is processed and identifies whether it is an orange or tomato, as shown here. In the field analysis panel, the purity of rice grain is given. Pesticides are sprayed according to the insects detected. The sensor network panel shows the graphical analysis of soil humidity, temperature, and soil moisture content. The power management panel shows the voltage level of solar, battery, and grid. There are various other features such as enabling the robotic arm, enabling alternative energies, automatic solar panel tracker, tank level monitoring, irrigation activation, alarm activation, fertilizer activation, humidity monitoring, wind speed, thermometer, rainfall, and wind direction monitoring.